Hey Becca, what are we learning today?
Factoring a quadratic, Part 2. In this lesson, we are going to be covering factoring a quadratic when a does not equal 1. I'll start with an example. 2x squared minus 5x minus 3. Now this looks like a quadratic equation that we've done before, but now we have a 2 as the coefficient in front of the x squared term. We're going to approach this problem the same way that we did before. We draw our x in the top, a times c, 2 times negative 3, negative 6, and in the bottom, we put our b term. In this case, b is negative 5. We're going to do the same thing where we need to find two numbers that multiply to equal negative 6 and add to equal negative 5. One has to be positive and one has to be negative because they have to multiply to be a negative number and they have to add to be a negative number. Let's think of some factors of negative 6. How about negative 3 and 2? Do they add to equal negative 5? Nope, we have to try again. What about negative 6 and 1? They multiply to equal negative 6 and they add to equal negative 5. So those are our two numbers. I'll put negative 6 over here and 1 over here. Now the trick to doing problems where a does not equal 1, we're just going to put the a term underneath the factors, kind of like a fraction. Now, is this a reducible fraction? Nope. But this one's reducible, so I'm going to reduce it. Negative 6 divided by 2 is just negative 3, but I'm going to leave a 1 term in the bottom, and you'll see why. Now, the only thing left to do is to add an x to our denominator terms. And in order to find our factored version of this equation, we have our two linear factors. We're going to write the bottom terms as the first term, and then we're going to write the top terms as the second term. Notice that this one is negative, so we're going to subtract it. And this term is positive, so we're going to add it. Now we've solved our equation by factoring it into two linear terms, x minus 3, 2x plus 1. Here's another example where our a term does not equal 1. In this case, a equals 3. Let's set this up the exact same way as before. Draw our x, a times c, 3 times 2, 6, and b goes on the bottom. In this case, b is 7. So we need two numbers that multiply to equal 6, add to equal 7. Notice that both these numbers are positive, so both of our factors are going to be positive. What are some factors of 6? What about 3 and 2? 3 and 2 multiply to equal 6, but they don't add to equal 7, they add to equal 5. So our only other choice is 6 and 1. So we'll put the 6 over here and the 1 over here. Now, because our a does not equal 1, we have to divide by our a term. In this case is 3. This is not a reducible fraction, so we're going to leave it. This one is reducible. 6 over 3 becomes 2 over 1. The last step, throw the x in the denominator, and then we will set up our linear factors. The first one will be 1x. In this case, we'll just put x, which is the same thing. Our second linear factor starts with a 3x. And now we're going to put the numerator as the second term. So the numerator for the first is 2, and it's positive. And the numerator for the second is 1, and that's also positive. So our factored equation, x plus 2, 3x plus 1. In this example, 4x squared plus 16x plus 15, our a term is 4. We'll start the process, draw our x. A times c goes up here. 4 times 15 is 60. And then our b term goes down here, in this case, 16. So we need two factors of 60 that multiply to equal 60 and add to equal 16. We've got a few choices here because 60 has a lot of factors. We can start with 15 and 4, but that's not going to work because 15 plus 4 equals 19, which is not what we need. So when you work through it, the two factors that work here are 10 and 6, because 10 times 6 is 60, and 10 plus 6 is 16. So we can put our terms in our little x. Now we divide by the a term. Now we have two reducible fractions here, so we can reduce both of these. 6 over 4 reduces if you divide both terms by 2. We are left with 3 over 2. And 10 over 4, you can also divide both of these terms by 2. And you're going to get 5 over 2. Last step, throw the x next to the denominator term and set up your linear factors. Our first one starts with a 2x, and our second one also starts with a 2x. Both of our numerators are positive, so we can put in the pluses. And then our first numerator is 5, and our second numerator is 3. And then you have your factored equation, 2x plus 5, 2x plus 3. Now if you were to FOIL this, you would get what we started with, and let's double check that. 2x times 2x, 4x squared. Now we'll do our inner terms. 5 times 2x is 10x. Outer terms, 2x times 3 is 6x. And our last term, 5 times 3 is 15. And if you were to combine the 10x and the 6x, you'd get the 16x. For our last example, we will work through 5x squared minus 11x plus 2. A times c up here. 5 times 2 is 10. And our b term down here, which is negative 11. So the factors need to multiply to equal 10 and add to equal negative 11. That means both numbers must be negative, because if they multiply to equal a positive number and add to equal a negative number. Now we could try 5 and 2 as factors of 10, but negative 5 and negative 2 will not add to equal negative 11. So our only other choice is negative 10 and negative 1, which they look like to add to negative 11. So we'll put our numbers in our x, and then we have to just divide by the a term, which in this case is 5. This is an irreducible fraction, so we're going to leave it how it is. And this fraction, negative 10 over 5, reduces to negative 2 over 1. Now the last step, add your x to the denominator and set up your linear factors. Our first factor is x, 1x, and our second factor starts with 5x. Notice that both factors have subtraction, and our first factor has a 2, and our second factor has a 1. So we're left with x minus 2, 5x minus 1. After watching this video and factoring a quadratic part 1, you should feel fluent in factoring any kind of factorable quadratic equation. But if you have any questions, you can leave it in the comments. And if you found this video helpful, give it 2 thumbs up and subscribe, because I'm posting videos every Monday and Thursday. Have a good day!